13.2. Again, this is 13.2 in your book. It's actually 14.2 in your math lab. So again, be aware of that. For some reason, those numbers are switched. So section 13.2 is going to get into talking about area, and we talked about perimeter a little bit in the end of section 13.1. And so now we're going to talk about area. We're going to talk about some conversions, how we measure land, and things of that sort. So we're going to jump right in. If this will, there we go. So first thing we're going to do is talk about how to find area using a model, a geoboard model. And so this is something that as you are teaching upper elementary school children, 5th grade, 6th grade, something like that, you would get into teaching area. Maybe even in 4th grade a little bit. And as you teach area, how to find area, using a geoboard can be really helpful. So what you can do is take a board, it's a little peg board essentially. You can get classroom sets. They're fairly cheap. Usually you can probably get your school to buy those for you if they don't already have them. And sets of rubber bands so that you can stretch out rubber bands around the different pegs and make these different shapes. And so the one way you can introduce area is to talk about how area is essentially the floor of a space. So if you were thinking about, okay, I'm going to lay flooring in my kitchen or in somewhere in my house, you need to know the area. And if let's say you're going to put down tile, and every tile is a foot by foot, it's a square foot, then you would need to know, well, how many square feet do I have so that I can know how many pieces of tile to get to make my flooring. And so one of the ways that you introduce area is by using geoboards and talk about the addition method. And so in the addition method, if you have some odd shape like we do here, you can think about breaking this shape into pieces. And you can do it a number of ways. So first thing I see is that if I were to take this and make a square, and then I were to take, let's say, again, you can do this a number of different ways. I would take this piece and make another square, and then maybe have a rectangle and another rectangle, and maybe break this like that. And so what you see then is that each square is one unit, one square unit. So if it were feet or meters or inches or centimeters or whatever the unit may be, that one square represents it. And so in the addition method, you can take the square footage of each section and be able to figure out how many square feet you have. So in this case, if you split it this way, you would have 1, 2, 3, 4, 5, 6, 7, 8, 9 square feet in this bigger square. And then you could add 1, 2, 3 in this piece. And then you have 1, 2, 3, 4 in this next square. And then you have some halves. So you've got this half and this half, that's another 1. And then you have this half and this half, which is another 1. And then you have this piece, which is also 1. And so when you add all those up, you see that you have 9 plus 3, which is 12, 12 plus 4, which is 16, and then 17, 18, 19 square units, whatever that is. Okay? And so you can separate this figure in a number of ways. So here's one way that our book illustrates it. So that you have this top rectangle shape, And then you have the purple one that is a longer shape here, longer rectangle. Same square here at the bottom, this green one, this one. And then again, you have this piece, the piece that I've put an X in. And then you still have all these little half units. And so, again, you can add all those up. And when you do, again, you should see that it's 19 square units. And since we don't know the unit, we're going to put square units. Or units squared is another way you could do that. And that is how our addition method works. Now, this is all assuming that you haven't talked about area formulas yet. And we have some. We have some area formulas. In fact, there's going to be several I'm going to give you here over the next little while. We're going to get into finding area of triangles and parallelograms and rectangles and squares and trapezoids and kites and all these different figures. We're going to talk about how to find the area. And so this is a good way to introduce the idea of area, because it helps your students, I hope it helps you too, to see, okay, that one square is a square unit. Then the next square is a square unit, and so on. And just being able to count those, hopefully, is pretty easy. Now, you also have what our book refers to as a rectangle method. And in this method, you construct a rectangle around the figure and then count up all the shaded areas and take them out. And so you can see here in this diagram, you've got this rectangle, this big rectangle, and it encompasses the shaded area. If we want to know the area of the shaded area, there's not really easy ways to determine that. And so if we can take out this section A, section B, section C, D, and E, well, then we can figure out what the area of that shaded area is. Take the total, subtract this part that's not shaded, leaves you the area of what is shaded. And so, in this case, if you take 1, 2, 3, 4 by 1, 2, 3, 4, 16 square units total. And then you take the area of each of these pieces. Now, we haven't talked about how to find the area of a triangle. The area of a triangle, which I'll give you again later, is 1/2 base times height. So the base would be this length, height would be this length, and so it's 1/2 of that. So let's start with part A. You have 1, 2, 3, and then 1, 2. So 1/2 times 2 times 3 gives this an area of 3 units, square units. Part B has an area of 1 square unit because it's 2 by 1, so 2 times 1 is 2, times 1/2, well, half of 2 is 1. And then you have the same thing here on part C. You have a length of 2, or a height and a base of 2 and 1, and so that 2 is going to give us 1 square unit. Part D is also 1 square unit, and then part E is also 1 square unit. And so from that 16, if you subtract the 3 plus 1 plus 1 plus 1 plus 1, then you're going to end up with 16 minus 7, which is 9. And so it's, again, you see that it is 9 square units. Okay, so that's another way to find area. And yes, we could have broken this down into pieces, but there's not any good rectangle pieces. And so then you've got to worry about finding an area of triangles, and that can be a little more complicated. So it's easier in this case to take out what's not shaded to find the area of what is shaded. If you have any questions about either of those methods of finding area, let me know. I think as we go further into this and we talk about area formulas, then that'll make a lot more sense. All right, so let's try one. So with this one, you'll notice that the big rectangle, in this case it's actually a square because we got 1, 2, 3, 4 units by 1, 2, 3, 4 units, so 16 total. But we can actually make a rectangle across here that does encompass every part of that shaded area. And if we can figure out the area of each of these pieces, then we can take that out and then have what's left. So let's do this. Let's take on the top here, let's take that square. So we're going to call this part A, this part B, this part C. This part we'll call D. And then for this last part, let's take this square across here like this. We'll call that part E. Let's call this one F. And then we'll take this bigger triangle, we'll call it G. Now, again, you can separate that in a number of ways. That's just a way that's going to be fairly easy for us, I think. So if we start with part A, again, using our triangle area formula, 1/2 base times height. Well, the base would be 1, height is 2, so 2 times 1 is 2, and then half of that is 1. And so 1 square unit for that piece. Part B has 1 square unit. Part C, just like part A, has 1 square unit. Part D is a half. Part F is a half. Part E is 1 unit. And then this part G, a little more to it. The base here is this piece across the bottom. And so it's 3 units. And then the height would be the 2 units up. So 3 times 2 is 6. And then half of that, because again, using the triangle formula. So that's going to be 3 square units. And so if you look at what do we have total in the big rectangle? Well, there's 1, 2, 3, 4 by 3. So it's 12 total. And then we're subtracting part A, which is 1. Part B, that's also 1. Part C is 1. Part D is a half. Part F is a half, so it's going to be 1 with those two fractions. Part E was 1, and then part G is 3. And so when you add all that up, you've got 3, 4, 5 with your 2 halves, 6, 7, 8. And so we have 12 minus 8, which should be 4 square units, or units squared. And you can see here on this, let me go back to there. If you have any questions about any of that, let me know. On the next slide though, I'm going to show you kind of how it's broken up. Again, this is the way the book does it in the next slide, but give you a chance to see all that if you need it. So here's the way the book broke it up. I think it's the same way we did. You've got part A, B, C, D, E, F, G, and again, finding the area of each of those, taking that away from the total. And so you had the 12 minus the 3, which was this piece. Part B was 1, C was a half, D was a half, E was 1, F was 1, G was 1. And so when you subtract all that, again, we get 4 square units. If you have any questions about that one, let me know. Again, we haven't really gotten into the formula part of this yet, but that is how we could go about finding this area using that rectangle method. All right, so let's talk about area conversions. This is something that is going to be useful to us, and it should make some sense. If you have in your notes from section 1, where we talked about converting from a meter to a kilometer, to a centimeter, and all those different conversions, we talked about how a meter is our base unit, then a decameter is 10 meters, and a hectometer is 100 meters, and a kilometer is 1,000 meters. And then going the other direction, a decimeter is a tenth of a meter, a centimeter is a hundredth of a meter, a millimeter is a thousandth of a meter. And so what happens is each of those are increasing or decreasing by a power of 10. Okay? Well, the same thing is true when we talk about area, but it's that unit squared. So for example, if you have a square and the side length is 1 meter for each side, well then we would say, well, that's 1 meter squared. But if you had 10 meters on each side, well then we would say the area is 100 meters squared. And so that's what you see here with the decameter. And if each side were 1,000, if each side were 100, then you would have 10,000 meters squared. And if each side were 1,000, you would have 1,000,000 meters squared, which gets us to the kilometer. Same thing going backwards the other direction. If you take a tenth of a meter, so let's say our side length is a tenth on each side. Well, when you multiply a tenth times a tenth to find the area, you end up with 100th meter squared, which is the 0.01. Okay, that's 100th. And so you can see how that would change. That's why these numbers are increasing and decreasing so quickly, is because you are squaring whatever that unit is. With the meter, 1 squared is still just 1. And so again, that's our base unit. And then as we square, we're going up or down. If we go towards kilometers or if we go down towards millimeters, again, that number gets bigger or smaller. So that's going to be important because we need to be able to convert area from one unit to another. So one thing that you maybe have done before. I know when my wife and I were building a house, we built our house about 5 years ago, and we were putting in flooring. And we were trying to figure out, okay, what is the square footage of our flooring? Square footage of a house is a little different than square footage for flooring. For example, you don't have to put flooring under cabinets, or you don't have to put flooring where the walls are. So the square footage of the house versus square footage of the flooring is a little bit different. And so as we're trying to figure out what is the square footage, if it were not exact feet, if it were, at some point a half a foot, well, I may need to convert that to inches to be able to get a more accurate measure. Or if I want to use yards, you don't typically use yards in in flooring, but you could. And so there has to be some conversion there. And so we need to know how this works. So we're going to look at that here in this example. So we want to go from 5 centimeters to millimeters. We want to convert that. And so if we look at the conversion, just like we've talked about conversion previously, we're going to say that 5 centimeters, again, we're going to write it over 1, and we're trying to get it converted to millimeters. Okay? So 1 centimeter is how many millimeters? Well, it's 100 millimeters squared. Now, this is centimeters squared for both of these, right? So 1 centimeter squared is 100 millimeters. Again, go back to our conversion. So if a centimeter, I think we did this in the last video, if a centimeter is 10 millimeters, I didn't get 10 of them in there, but you have 10 millimeters in that 1 centimeter. Well, then if that's your side length, then 1 centimeter has to be 100 millimeters squared. And so that's what we've got here. We've got 1 centimeter is 100 millimeters squared. And we're trying to get it to millimeters squared. And it's 2 m's, not just 1. And so the centimeter squared cancels. And so we can multiply now because now we have millimeters squared. 5 times 100 is 500 millimeters squared. And then we don't have anything on the bottom except 1. And so that must be our answer. And again, you can say that's what happened here. Again, just trying to go from one direction to the other and following that conversion table is what we're going to do. Now, notice the next one. We're converting from meters squared. So we've got 124 million meters squared. Again, that's an area, right? And we want to convert that to kilometers squared. Okay, so again, going to do the same type of conversion. We're going to take 124 million meters squared. Again, I like to put it over 1. And that's going to convert, hopefully, to kilometers. Well, how many millimeters squared are in a kilometer? Well, again, if you go back here, we see that a million meters squared is 1 kilometer squared. And so we're going to say a million meters squared is 1 kilometer squared, or kilometer squared. And so we'll punch that in the calculator. Again, 124 million divided by 1 million should be 124 kilometers squared. And again, notice our meters canceled out. And so then we're left with kilometers. Again, the key to this is just knowing how much each unit is and trying to figure out what do I do to get there. So if I know a ratio between meters and kilometers like I do here, then it's not hard. If I know a relationship to centimeters and millimeters, which we do in the first one, it's not all that hard. If you have to go through multiple conversions, it's a little more difficult. But hopefully this one is not too bad. If you have any questions about this one, let me know. I'll be glad to answer any questions you have. Now, as we talk about area, so there's that one, by the way. As we talk about area, we're going to get into land measure. Because usually when we're talking about large area, it a lot of times has to do with land. You talk about, somebody owns a lot of land. Well, how do we talk about that? How do we describe what that, the area of that land? And so in English units, we typically will use the, we'll talk about English in a minute. Let me talk about this first. We're converting from millimeters and centimeters and kilometers and meters and all that. We also have the English version of that, where we have a square foot, which is what we deal with when we talk about housing. Your house is measured in so many square feet. So maybe your house is 2,000 square feet, or maybe it's 3,000 square feet, or whatever square footage. And again, you can think about a 1 by 1 square, 1 foot by 1 foot square, and that square footage tells us how many of those would fit into that house. Okay, without overlapping, without without any gaps, fitting in that house perfectly. And so when we talk about square footage, that is also equivalent to a ninth of a yard squared, because we know a foot is a third of a yard, right? So a third times a third is a ninth. We also know that a foot is 12 inches, and so if you convert it to inches squared, it's 144. 12 times 12 inches squared. We can also do the same thing with yards. It is 9 feet squared, because again, a yard is 3 feet by 3 feet, and so that'd be 9 feet squared. Or we can convert it to inches. 36 inches we know is a yard. 36 times 36 is 1296. That's where this number comes from. And then we can talk about mileage and do the same thing. So each mile is 5,280 feet. So if you square that, if you do that on both sides of a square mile, you would have 27,878,400 feet. So that's this measurement. If you were to do it by the yardage, a mile is 1,760 yards. And so again, if you square that, you get this unit in square yardage. Okay. So now this is where I was trying to get to, the land measure. So when we talk about land measurement, we typically talk from the English standpoint about acres. So when I bought my house, or when I built my house, I bought land, and I bought acreage. I had a surveyor come out, he surveyed it, I bought 2 acres of land. Okay, that acreage is not a measurement that you just can kind of look at and say, oh, well, that's an acre. It's kind of hard to judge. And we're going to talk in a few minutes about how big an acre is. Essentially, an acre is about 208 feet squared. Okay? So, well, no, I'm sorry, 208 by 208. And so you'd have to square that to get the area. But it's 208, let me do it this way. 208 by 208 would be about how big an acre is. Again, it's not accurate. It's a little slightly off, but it is pretty close. We also can talk about land in square mileage. Again, those are really the only way we talk about land. You know, if you're buying a small piece of land, you talk about acreage. You can buy a half acre, you can buy 5 acres, you can buy 2 acres. You know, you could buy an acreage. Or if it's a very, very large amount, like if we're talking about the state of Mississippi, we may talk about how many square miles it is. Okay, so depending on the size of the land we're talking about depends on which one we use. From the metric side, we don't use these very often. I don't know that I've ever heard these actually used, but you have some similar measurements. The first one is an R, A-R-E. It is sort of like the acre. And then you have a hectare, which is obviously going to be a little bit bigger than that. And then you have a square kilometer. So that's going to be pretty close to our square mileage in the English unit system. But we can talk about square kilometers as well. So, here's how it all sort of works. In the metric system, an R, again A-R-E, is 100 meters squared. So that's 10 meters by 10 meters. Okay, so you can think about a square 10 meters by 10 meters would give us 100 meters squared for that area. That would be an R. A hectare, so the next one, HA is how we abbreviate that, is 100 R's or 10,000 meters squared. Or you could even do it as 1 hectometer squared. Okay, again, it all goes back to being on a base of 10. And we'll use this in just a few minutes. And then a kilometer squared is 1,000,000 meters squared. Excuse me. So again, it's 1,000 by 1,000 meters. So 1 kilometer by 1 kilometer squared. Or it's 100 hectare. So if you think about a hectare being 10,000 meters squared, then 100 of those would be a kilometer squared. Again, we don't use those a whole lot. What we do tend to use in the United States is we use acre and square mileage. And so an acre is 4,840 yards squared. So if you take, just do a quick calculation here. If you take 4,840 and you take the square root of that, you will see that it's 69 by 69-ish, pretty close to that. And that's, again, yardage. From a foot standpoint, it's about 208 by 208. So if you wanted to talk about, well, what's the area of an acre in square footage, you would say 208 times 208, which is about 43,264 square feet. Again, not an exact measurement because it's not exactly 208, but it's pretty close. Okay? And so we talk about an acre, it's about 43,000 square feet, a little over that. But we talk about square yardage because it's a much more accurate measurement than having to round with the square footage. Okay? And then 1 mile squared is 640 acres. So if you were to think about each of these acres being a square piece, right, it would take 640 of those to be a square mile. You probably know people that own a lot of land, and you may know people that own 200 or 300 acres of land. My grandfather owns about probably 300 acres of land, which when you think about that from a square mileage standpoint, it's about a half square mile that he would own. And so, just to kind of put that in perspective for you, if you know somebody that owns a lot of land, most people, if they own a lot of land, it may be 20 acres, 30 acres, something like that. It's not very often you find people that own hundreds of acres. Sometimes you do. If you happen to get into the 640 range, then you're looking at that person being able to say, well, I own a square mile. Okay, so just kind of be aware of that, just for perspective. All right, so let's look at some examples. Example A says a square field has sides of 400 meters, and you may want to draw a picture here that could be helpful. So you've got 400 meters as a side, and we want to find the area, but we want to find it in hectares. All right, so let's think about this. So the area in meters squared would be 400 times 400, which is 160,000 meters squared. And so we need to take 160,000 and convert that to the hectare. So 160,000 meters squared is going to convert to hectares because 1 hectare is 10,000 meters squared. Again, you can go back to our chart and see that. And so if that's the case, then when you do this division, you're going to end up with 16 hectare that make up this area. So again, you can see that played out there. Notice that the hectare, because it is a square unit, we don't have to put squared. It's not the hectare squared. The hectare is a square unit. Okay? Just the nature of that unit itself. So we don't have to put it's this many hectare squared. Just like we don't say, well, it's 4 acres squared. An acre, by definition, is a square. Okay? So just kind of be aware of that. Now, look at the next one. It says a square field has a side of 400 yards. We want to find the area of the field in acres. So again, it might be helpful to think about drawing a picture, just to kind of have a little sketch here to think about. So if it's 400 yards for each side, that's 400 by 400. So the area of that field would have to be, again, 160,000 yards squared. And so we need to convert that to acreage. Well, we can do that. 160,000 yards squared can convert to acres because, again, if you go back to our chart, we said that 1 acre is 4,840 yards squared. And so, again, the yard squared is going to cancel. We're going to get to the acre. And so when you take the 160,000 and divide it by 4,840, you end up with approximately 33.06. I think the slide here is going to round it to 0.1 acres. So again, you can see there it rounds it to 33.1. But it's taking that yardage and converting it to the acres. If you have any questions about these conversions, let me know. I'll be glad to answer any questions you have. I'm going to stop this video. Our next video will begin to get into area in quite a bit of detail, and we'll start looking at how to find the area of various shapes. So if you have questions about any of this we've done so far, shoot